Hello everyone, welcome to my video on computing land and water productivity using data from WaPOR and QGIS open source software. The main objective of this lecture is to show you how to compute seasonal biomass, yield and water productivity using QGIS open source software for the crop sugarcane over our study area. To recap, our study area is Xinawane with a major crop of sugarcane located in the southern part of Mozambique. The crop season, the sugarcane season is 12 months from September to October the following year. Again, to recap, we use WaPOR data to compute water productivity. And the earlier lectures you saw how to download WaPOR data, how to compute seasonal data from these variables, and you also saw how to compute different performance indicators. Data for this exercise can be found in this GitHub repository, and if you download this repository you will find this folder called data. And in the earlier videos we saw how to compute seasonal maps from this decadal maps downloaded from WaPOR. To compute water productivity, we have to follow 3 steps, and let us do that step by step in QGIS. The first step is to compute above ground biomass using this particular equation. And the unit of the above ground biomass we calculate here is in kilogram per hectare. OT is above ground over total biomass production ratio. FC is the light use efficiency correction factor. NPP is the seasonal net primary production in gram carbon per meter square per season, which is computed from WaPOR data, and MC is the moisture content. For AOT, FC and MC, these values are given from literature. And we will use these values in QGIS to compute biomass. So let us open QGIS. Please remember to open QGIS with GRASS so that you can make use of GRASS modules as well. Once the QGIS is open, please open the recently saved project called seasonal if you have followed the earlier lectures, or else you can also open an empty project and open the seasonal WaPOR translation and seasonal NPP file, because we need these two to compute water productivity. So let us follow this equation to compute above ground biomass from NPP. So I'll open raster calculator. So the equation is AOT, which is 0.8 multiplied by FC, the correction factor, which is 1.6 multiplied by I will open 2 brackets here, NPP multiplied by 22.222. I'll close 1 bracket here, divided by, open a bracket again, 1 minus MC, which is the moisture content in the fresh biomass, is given as 0.7, close all the brackets. I'll save the output layer as seasonal above ground biomass and run this expression. So you can see that we already have seasonal AGBP here in kilogram per hectare. Let's go back to the slides and let's move to step 2. The next step is to compute crop yield using this formula, harvest index multiplied by biomass. The biomass which we already calculated in the step 1 in kilogram per hectare. But the harvest index is considered as 1 for sugarcane, and WaPOR is also developed based on this harvest index. So we'll consider harvest index as 1. So we don't have to specifically apply this equation because the crop yield is going to be the same as biomass, given that the crop is sugarcane in this case. So there's some assumption here. So you may have to vary it based on case by case. So let's move to step 3 and the final step, calculate crop water productivity in kilogram per meter cube. So to do that, we will use this particular equation, yield divided by actual evapotranspiration multiplied by 10, which will convert the unit into kilogram per meter cube, which will give the crop water productivity for sugarcane. So I'll go back to QGIS, save the project. I will open as a calculator again. So instead of yield, I will use above ground biomass production because both are same in this case, as harvest index is 1. So I will select AGPP divided by, I will open a bracket, set ATI multiplied by 10, close the bracket, and I'll give a name here. So I'll give it as seasonal WPY yield based water productivity, and save and run this equation, and you can see that the water productivity map. You can see the histogram of this one here of water productivity, and you can see that the majority of the values vary from, let's say, 5 to 8. We can also give a symbology based on that. We restrict these values to 8. So this is the water productivity map for you, and you can again use R.Univar or rasterized statistics to compute some statistics on water productivity. So thank you. This was my lecture on computing water productivity in QGIS.